All right, welcome back to the last trig lesson. This, again, like I mentioned last time, this is about solving problems involving more than one single right triangle. Okay, so here, I mean, you have all the tools to solve the problem, but it just, it has more than one, so it's a little bit more complex, but it's not that bad. Okay, let's look at the example here. This is calculate the length of xy to the nearest tenth of a centimeter. Okay, so we're solving for xy. That's what we're solving for here. Now you can see, hopefully you see there are three triangles here. There's this one right here. Okay, and that's a right triangle. There is this triangle right here, which is also a right triangle. And there is the entire thingy, right? That's this triangle, which we don't know if it's a right triangle or not, okay? But that's okay. Let's see how we're gonna solve this problem here. Again, the goal is to solve for xy. That's the question. Now, if we simply look at this triangle right here, we can't solve for the length xy right away or directly from here because the only thing that we know is 22 degrees. We don't know anything else, okay? So we can't solve for x directly from that triangle. However, we can look at this triangle, and this triangle has more than one piece of information. It is a right triangle, right? That's given to us. We know this is 20 degrees, and we know that this part is 8.4 centimeter. So we have more than adequate information to solve for the rest of the triangle, actually. But anyways, here is the right angle. Therefore, let's name the side. Here's the hypotenuse side. Here's 20 degrees. This would be the opposite side, and this is the adjacent side. Now, which side is going to help us to solve the question? Does it help if we know the adjacent side? Not really, because adjacent side is not any part of the triangle XYW, right? So if we solve for opposite side, that means we actually get more information about the smaller triangle XYW. So that's probably, or WXY, or whichever you want to call it. So that's the that probably is the side we want to solve, right? The opposite side, okay? So if we're solving for the opposite side and we know the hypotenuse, then that just means we have to use the sine ratio. So sine 20 degrees is, let me call this the h, the opposite side, or the height, over the hypotenuse side, which is 8.4. Okay, to solve for h, you simply multiply both sides by 8.4, so 8.4 sine 20, and if you put that into a calculator, you should get 2.87, so let me call that 2.9 centimeter. And then because we know that, let me just redraw this triangle here. We know that's 2.9, and this is 22 degrees, then we can solve for x, right? Because, here we go, this is the hypotenuse, this is the opposite side, which makes this the adjacent side. So we know the adjacent side, and we're solving for hypotenuse side, so we can use cosine. So cosine 22 degrees is equal to adjacent, which is 2.9 over hypotenuse of x. And therefore, to solve for x, you simply divide 2.9 with cosine 22. Now, let me just it's a helpful reminder, maybe. It's not really a reminder, it's a first time. We try to minimize rounding as much as possible, okay? So obviously this 2.9 is a rounded number, so therefore this is rounded and that's rounded. Now on the calculator, once you get the value, it's actually 2.87296-ish. You don't clear it, okay? You actually want to use the number, the value on the calculator, and just take that and then divide it by cosine 22. Okay, so whatever you have on the screen, just use that number. So you don't need to do anything, just use the number and then divide it by cosine 22. Then you actually get the final answer of 3.1 centimeter. Okay, that's the final answer. If you use 2.9 instead of using the actual answer on the screen, you actually end up with 3, or actually in this case it doesn't change anything, it's still 3.1. But the second decimal place is actually different, okay? So make sure you use the answer on the calculator some calculators has an answer button, so you could use that as well if you wanted to. And don't use the rounded value, okay? So what I mean here is don't use 2.9, use the answer on the screen, okay? And divide that by cosine 22. All right, example 2. Let's try this together. It says a surveyor stands at a window on the 9th floor of an office tower. He uses a clinometer to measure the angles of elevation. We'll actually use this later on after the test, I think. Anyways, it's a tool to measure angles. He uses a clinometer to measure the angles of elevation and depression of the top and the base of the taller building. Okay, so you can see there's the person, that's the taller building, that's the bottom of, or that's the top of the taller building, that's the bottom of the taller building. And the angle of elevation is 31 degrees, the angle of depression is 42 degrees. The surveyor sketches this plan, and here we go, of the measurements. Determine the height of the taller building, so we're solving for this. Okay, determine the height of the taller building to the nearest tenth of a meter. Okay, so we already know that this is 39. Okay, we already know this is 39 right here. That's given to us. But we're looking for the entire height, which means we actually need to solve for this, right? Because if we know x, the height of the taller building would simply be x plus 39. Okay, now the question is, how do we solve for x? Again, if you look at this triangle, we can't solve for x directly because we only know the angle. Okay, we don't know anything else, really. Well, actually, we know the angle 90 degrees there as well. But those are the two angles that we know, and that's not enough, okay, to solve for x. However, we do have a second triangle down here, which we do have plenty of information. Again, that's 90 degrees. This is 42 degrees. And we know the opposite side from 42 degrees is 39. Okay, well, then we still have the hypotenuse side here. And we have the adjacent side here. Okay, so, well, I think quite clearly we don't need to solve for hypotenuse because that's not really helpful to solve for x. Adjacent side is the one we need to solve for first because then that's part of the triangle on the top and we can use that information to solve for x. Okay, so we have the opposite side and we're solving for adjacent side, so we have to use the tangent ratio. So tangent of the angle 42 degrees, because that's the angle we look from, is opposite over adjacent. Let me call that y here. Okay, so tangent 42 is equal to 39 over y. Oh, so to solve for y, you simply go 39 divided by tangent 42. And you would get tangent 42. This is 43.3 meters. Okay, and now we have this as we have that side and we're solving for x. Okay, so actually I am going to draw this in blue. Okay, so here we go. Actually, quite luckily, because here's the angle theta, so this is the opposite side. The adjacent side for the red triangle is actually still the adjacent side for the blue triangle, and that is the hypotenuse, but we are not really interested in that. So we are trying to solve for the opposite side, and again, we know the adjacent side, so that is the tangent ratio. Whoa. That is the tangent ratio. The tangent of the angle 31 degrees should equal to opposite side, which we don't know, divided by the adjacent side, which is 43.3. And to solve for x, you simply multiply both sides by 43.3. And again, when you put that into a calculator, don't actually use 43.3. Just use the answer on the calculator and use that, and you go times tangent 31. So you avoid rounding until the very, very last step, which will give you 26.0 meters. Okay, so avoid rounding if possible. Okay. Here's the third example. I will show you and I'll let you do the last one on your own. Okay. So it says determine the length of AB to the nearest tenth. So this is the side we're trying to solve. Okay, here's x. Well, we have three right triangles, and Well, the only triangle that has a side length is BCD. Okay, now you can see clearly we need to solve for triangle 1 and then triangle 2 and triangle 3, right, in that order. So the side that is shared between 1 and 2 is this, so that's the side we need to solve for first. So here's the angle 40 degrees. This is the opposite side. That gives us this, the hypotenuse side, because that's opposite from 90 degrees. And this is the adjacent side. So we're trying to solve for hypotenuse, and we know the adjacent side, so that is cosine. So cosine 40 degrees is equal to adjacent 8 over hypotenuse. Let me call that y here. So to solve for y, oops, not 8 equals, y equals 8 divided by cosine 40 degrees. And that is going to give us 40, 10.4. Okay, so now we know that y is 10.4. We can then use our second triangle. Okay, second triangle to solve for, I guess, EB, right? So this is the angle 42. Y is no longer the hypotenuse side because, again, here's the angle. This is the hypotenuse for the red triangle. This is the opposite side. So y in the blue triangle, that was the hypotenuse, but now y in the red triangle is actually the adjacent side. Okay, so a little bit confusing here, but you just gotta be careful, okay? So we are trying to solve for hypotenuse, and we know the adjacent side. Therefore, again, we are going to use cosine ratio. So cosine of the angle 42 degrees is equal to adjacent, which we do know now, it's 10.4, but we don't know the hypotenuse. Let's call that z. So z is going to equal to 10.4 divided by cosine 42 degrees. And again, do not actually use the number 10.4. Just take the number on the screen and then just divide it by cosine 42. So you avoid rounding errors. And this will give us 14.1 centimeter. Okay. And so now we can then use the information that we just got, and we can then solve for the last triangle. Let me redraw that using green now, right? Here is the last triangle we need to solve for. And we're solving for x. This is 25 degrees. So again, this is now the hypotenuse. This is now the opposite side. And again, the hypotenuse for the red triangle actually is the adjacent side for the green triangle. So again, we know adjacent, we're solving for hypotenuse, we have to use cosine. So cosine 25 degrees is equal to adjacent, which is now 14.1. That's the number we just got, over x. Okay, so then we can then just solve for x by dividing. So 14.1 over cosine 25 degrees. Again, don't actually use 14.1, use the number, which is 14.05279.019 on your screen. And take that divided by cosine 25. And you can see the more you round, the more off it will be at the end. Okay, so finally, this is our final step. So you can really round here, and that is 15.5 centimeter. Okay, don't forget a unit as well. All right, so this one, it involved 3 triangles. Not that bad, right? It's not that bad. Okay, last one. Give it a try. Okay. Well, I'll read the question first. This is a lighthouse keep 300 feet above sea level, spots 2 ships directly offshore. The angle of depression to ship A is 6 degrees. The angle of depression to ship B is 4.5 degrees. How far apart are the 2 ships? So we are solving for this, right? That's what we're solving for. The distance between the 2 ships. So we're solving for Y. Okay, good luck. Pause the video and give it a try. Okay, so I mean, the diagram already labeled x for you, so I guess we need to solve for x as well, okay? Because to solve for y, the idea is to solve for d to b, and then solve for d to a, and then you go dB minus dA, and that will give you AB. Okay, so that's the idea. So clearly we have two triangles here. We can solve for dB by using the big triangle. Okay, and that's a right triangle. This is 4.5 degrees. Therefore, this is the opposite side. That's the hypotenuse side, but we're not really interested in that. We are solving for the adjacent side. Okay, so we have to use tangent because we know opposite and we're solving for adjacent. So tangent of the angle 4.5 degrees is equal to the opposite side over, let's call this y, the adjacent side. So solving for y equals 300 divided by tangent 4.5 degrees. Put that into calculator. You would get 3,811 point, let's round to one decimal place, that's okay, 0.9 feet. Okay, because that's what the unit is in the question, so that would be the unit for our answer. So that's y, or that's dB. Now once we know that, we can then solve for dA. Okay, so that's the smaller triangle right here. Okay, starting to get a little bit confusing here because there's a lot of red line, blue lines, and soon green lines. Well, I guess I don't really need to draw more for the green because that's just the subtraction of the two. So again, this is the opposite side. That doesn't change because that's opposite from that angle. That's still the hypotenuse side, again, which I'm not interested in. And x. Oh, shoot, I shouldn't use y because y is the one that we wanted to solve. Okay, let me change that. Instead of y, let me call that z then. Okay, let's change that to a z because we already have y labeled there. Okay, my bad. We can solve for x. Again, that is, we know the opposite side and we're trying to solve for the adjacent side. Okay, so tangent of 6 degrees is equal to opposite, 300 feet, divided by adjacent, which we don't know, x. So x equals 300 divided by tangent 6. And that will give us, I have no idea, let's put it into calculator, tangent 6 degrees, 2,854.3 feet. Okay, and therefore finally for the green, again, like I said earlier, green is simply, so y is simply going to be z minus x, right? It's just the entire length, entire base minus part of the base, right? And that will give you the rest. So that is going to be 3,811.9 minus 2,854.3. Now, obviously, we can keep this value from your calculator, but this we can't because that was from the previous step. So there will be some rounding errors here. That's okay. I mean, we did what we can. But for the 2,854.3, use the answer button on the calculator, okay? So you don't need to round for the 2,854.3. But it's going to be 3,811.9 minus answer. Okay, again, use the answer button on the calculator. And this will give you 957.6 feet as your final answer. Okay, so that is it for this trig chapter. Again, the last lesson was involving more than one single triangle. That's okay, it's not that bad, right? You just need to find out what information do I need to get first in order to solve for my final question, right? So, I would look at the question first and think about, come up with the idea on how you should approach the question, then carry out the execution, right? Then execute it. That's probably the best way to do it, okay? All right, do some practice questions. Let me know if you need some help. Otherwise, good luck.